welcome to today's episode of Rawkode Live. I'm your host, Rawkode, and I'm very pleased today to be covering the Cortex project, a time series, horizontally scalable time series database, which is part of the Cloud Native Foundation as an incubating project. I want to first thank my employer, Equinix Metal. They give me the time to invest in making this show and producing content that we can all learn together with. So thank you very much to Equinix Metal. They have given me a code, rawcode-live. You can use this to sign up for the Bare Metal Cloud and get $50 of compute time. Now you can use that $50, wisely and use smaller boxes and have lots of compute time, or you can splurge it really, really quickly in a few hours with some massive bare metal machines. So, pick your poison. We have a Discord community where we allow people to chat about these episodes afterwards. So if you're not watching live and you have questions, feel free to drop in and chat to us there. Of course, if you are watching live, please get involved. Leave us comments in the YouTube section, the YouTube comment section, and we'll be happy to tackle them as we go. As I said, we're going to cover Cortex today, and I have a fantastic guest with me. So let's bring in Ganesh Vernikar. How are you, Ganesh?
I'm good. How are you, David?
Yeah, I'm very well. Thank you very much. So you are an engineer at Grafana, a
Yes.
maintainer on the Prometheus project, and a contributor to Cortex. Can you
Yeah.
just maybe add a little bit of flavor to that? Tell us a little bit more about
Yeah.
yourself, please.
Yeah. So I'm a software engineer at Grafana Labs, as David said, and I have been a maintainer of Prometheus project since 1.5 years, and I maintain the TSDB part of the Prometheus and sometimes work on the PromQL part. And since I joined Grafana because we have Cortex as our backend for the hosted solutions, I also contribute to Cortex regularly. So that's about the background that I could say.
Nice. I mean, not just a maintainer of Prometheus, but the actual TSDB section as well. I mean, it takes a very
Yeah.
special kind of person to build a database and work on a database. So that's, I'm glad it's you and not me. That's for sure. So, can you tell me, just when it comes to Cortex, right? There are many flavors of Prometheus, kind of I don't know, evolutions, I guess. Other
Yeah.
projects that are using Prometheus as a core and the API and adopting some of those best practices that Prometheus has kind of brought forward as we all adopted cloud native and Kubernetes. So can you just tell us why Cortex exists? What space is it trying to fill inside of here?
Yeah, definitely. So, this Cortex or any other project like Thanos, M3, Victoria Matrix, etc., they don't aim to replace Prometheus as is, but they extend what we can do with the Prometheus data. Before we can talk about why we need Cortex, let's talk about what's lacking in Prometheus and what this gap fills in. I actually made some notes so that I don't forget telling something in this. Yeah. So first, talking about the global view. Let's say you have Prometheus in multiple Kubernetes cluster, and you want to have a global view of all the Prometheus that you have installed in multiple clusters that you have. That's actually doable in Prometheus, but there is something called Prometheus Federation, where you run another Prometheus which scrapes the existing Prometheus and you scrape out of a Prometheus, but still you're limited by what a Prometheus can do on a single machine, which is super high, but still there's some lacking. But let's say you want to do HA, so you have two Prometheus scraping the same stuff, and you have a federation on those two Prometheus to have a global view and multiple other Prometheus. But again, if you have a single Prometheus for Federation, that's a single point of failure and you don't have HA. So we'll have HA for Prometheus. So you can see where it's going. It's getting kind of messy handling multiple Prometheus. So that's one of them. Cortex acts as a centralized database where you have all the data of all the Prometheus of your cluster and you have a centralized view. Another thing, multi-tenancy. So when you are a large organization, you would like to have you have different teams, and sometimes you might want to give access to a team for some part of the data and not everything. And Prometheus is not multi-tenant natively. So Cortex is multi-tenant natively, where if you can say that some group of Prometheus servers are of one tenant, some are other tenants, and everything is again in a centralized store. And yeah, Prometheus scales very well vertically, and but there is a limit of how much memory or how much CPU that you can have. So Cortex fills that gap by having a horizontally distributed database where you can scale horizontally unlimited metrics. So those are few things that I can see right now. Yeah.
Awesome. Those are things that I think, as as so many people are adopting Kubernetes, horizontal scalability is now almost just something that we take for granted.
Yeah.
And well, at least in some applications. But when it comes to databases, this is a completely different domain, a completely different problem,
Hmm.
and a really good space that Cortex is trying to kind of fill a void and solve some challenges. So I'm really excited to see how we can get started with Cortex and how we can use it for all of our metrics.
Yeah.
Okay, so we're going to. I think today's a little bit different from normal. We're going to split this into multiple sections. So we're going to cover the installation of Cortex and some hardware that I pre-configured. So, let
Yeah.
me get my screen on. So this is Equinix Little Console. I have spun up two bare metal machines, Cortex 1 and Cortex 2. I don't know if we need them, but that's all right. I like to have them available. Now, I believe we're going to run through getting started on one
Yes.
of these machines.
Yes.
And then you want to cover a little bit of the architecture, which I'm super excited for. And I
Yes.
think you've got a demo, and then we're going to try and rebuild that demo ourselves on this compute. That sound
Yeah.
about right? Okay, awesome.
Yeah.
So shall
Or
we
maybe
start?
we could be bold and just do all the demo in your machine itself. It should be simple.
I mean, I do like to be bold. Yeah, definitely. I've broken a few things on this show before, and I'm not scared of doing that again. So,
Yeah.
what do you want to do first? Shall we get Cortex installed on one of these machines and go through
Yeah,
the
let's get started with the doc. So, uh, in the document, you can click on documentation and in click on getting started. We have all the steps that we can do, and click on block storage, which is going to be the next default storage, which does not involve an index store. Yep.
Okay, so
First thing is to clone the repo.
the Prometheus repository? No,
Cortex.
Cortex. Gotcha.
Yeah, you can clone both of them. Like uh, Cortex is a long-term storage solution for Prometheus, so Prometheus has to push data to Cortex. So we will have both Prometheus and Cortex running.
All right, perfect. So let's get this cloned then. Good, it's fast. There's always that doubt in your head. You're like, crap, how big is this? What's the connection going to be like? But when things just work, I'm a happy man. So,
Yeah.
all right, so this is the Cortex clone. Based
Yes.
on what we just seen here, I'm assuming you just want me to go ahead and just try and build this.
Build. Yes. That's all. It's simple. It's just a single binary. Whether you scale horizontally or want to run on a single node, it's always a single binary.
Oh, nice. And how long does the build take?
It should be pretty quick. Like the first build is always going to be slow. Yeah, it's done.
It's all right. I think I threw a fair bit amount, blah, 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 words. I think I threw a fair amount of hardware at this. Yeah, we've got 64
Yeah.
cores and 400 gig of RAM, so it should be
Yeah.
snappy. So I'm assuming now I have a Cortex binary, which I do.
Yes. And you need to pass some flags, like you need the config. That's there in the getting started.
Ah,
Yeah.
so that was
You
just a
have
bit
a
bit too
yeah,
hasty.
you have a config already given to you to get started.
All right. Do you mind if I just pop that open and we take a quick look?
Yeah, sure. Yeah.
Okay.
This has few stuff which are not required right now, but still it's there in the getting started.
Yeah, I'm just always nosy, curious. I like to kind of see. So,
Yeah.
all right. Okay.
Yeah.
Cool.
So
So,
once we are done with like the hands-on, I could explain what's in the config and the architecture, what's running inside. That should
okay.
be useful. Yeah, I expect this error. So if you can see what network interfaces you have with IW config, I think we need to change something in the config, or we can use LO, the local host. If you open the configuration file, we got to change a small thing. Yeah.
Okay. So. Let's see.
If you go to the top, yeah, there is, yeah, like bottom of this section, there is ingester and life cycler. Just below the commented out address, you can add no, you can comment it out. You can add a section called interface and assign it to LO. Just
Oh,
assign it to LO, and it should be all good, I guess. Like by default, it uses
right. Okay.
ETH0 in. Yeah,
Okay.
yeah. I hope
Let me.
it works right now.
Uh,
Oh,
person YAML. It's
okay.
low, maybe special. Let's just make sure
I
it just.
have I have a workaround for this. Hang on.
So, what is the? Why is it? What's the problem? I don't think I understand exactly what's going on.
It needs a network interface to talk through. Give me a second. Why do I not have that handy?
Just tackle the wee. Yeah, I've often. I had a comment saying, "Oof, big machine." Yeah, I always seem to over provision, but I think that's just one of the joys of working for like a
Mm.
cloud company that focuses on bare metal. Like they don't, their smallest machine is still quite a large machine, and I love being able to kind of show that off a little bit.
Yeah. So I'm just sharing one more small flag that you can add in the
Yeah.
chat.
Okay.
Yeah.
Let's see.
Along with the config file thing, you can add this following config line.
Okay, so we're just going to add this
Yes.
ingester.lifecycler.interface.
Yeah.
So is that just overriding what's inside the YAML with?
Yes. Yeah. It's just overriding the defaults.
So I'm going to remove that line from the config then, because it seems
Yes.
that that's causing. I'm guessing. Feel free to correct me, but it seems like it
Yeah.
just doesn't like that.
Yeah.
Where was that low?
I think it's a different file. There are multiple files.
Uh, yeah, sorry. Config blocks. All right. This time it's going to work, right?
Fingers crossed.
Ta-da!
Yay. So
Phew.
I guess if you could verify the first log, I guess it's exposing the port 9009, if I'm right. If you go a little bit up, it will be useful to
Yeah,
update the config.
9009. There we go.
Yeah, yeah. So in the next tab, we can start running Prometheus.
Okay, no worries. Let
Yeah,
me just
so
start
that we
this
can
up.
push some data.
Grab this IP address again, so that we don't have
Yeah,
to. I guess I could have just backgrounded it, but we'll leave it running so the logs are visible if needed. So the Prometheus now, are we building that from source or?
yeah. We could do it from source, or we could just get the binary. It should be source should be faster.
Yeah, probably. I mean, I don't even know if Prometheus is available on the Ubuntu repository, so we'll
Yeah,
just
it is.
clone. It is.
Yeah.
Then that means I can just start it with systemd. Okay, let's do that.
Oh, okay. That might be a little outdated, or yeah, it should be fine. But it would be simpler if we do via the source because we could change some config and other stuff.
All right. Okay. We'll go with your judgment here. Mine's is
Yeah,
always wrong. So,
yeah. Because I'm familiar with the repository stuff, so let's go with that.
all right. So let's just quickly build that.
Yeah,
Hopefully, it won't take too long either.
yeah. Until then we can see the config that we need to change. Like there is a default config where we need to add few stuff.
Okay. So right away, I'm looking at this bit of YAML and I see something that I'm vaguely familiar with, but it'd be really cool if we could take the opportunity just to kind of make sure my knowledge here isn't wrong.
Sure.
Now, I see remote write, and this is something that a lot of people in the Prometheus community and users are always talk about Prometheus' ability for remote reads and writes. Can we just cover
Yes.
how Cortex is integrating, or is that part of your architecture thing? And I'm just jumping the gun a little
Yeah.
bit.
Yeah. So when you talk about all these long-term storages, it has to get data somehow from the Prometheus. So Cortex uses the remote write where as and when Prometheus scrapes the samples and stores it in its own TSDB, it pushes to this URL. So this URL turns out to be Cortex here, so it pushes the samples to Cortex. That's how Cortex gets all the samples that it stores. So when you have multiple Prometheus instances, all of them point to the same Cortex, and all of them just push to the same Cortex.
Okay, so does that mean that Cortex is just a backing store? So Prometheus is still doing the scraping
Yeah,
intervals and
Prometheus.
fetching the metrics. Okay.
Yeah, Prometheus does fetching it. Cortex acts like a storing uh, thing, and you can also query Cortex.
Right. Excellent. Okay. I think I actually understood that. So Prometheus.yaml
.yaml, and
and
yeah, you can
remove
just add
or
the thing.
just add it. Right.
Yeah,
Got it.
just add it at the end. And you could make one more addition, like in the scrape config, you can also scrape Cortex. Like just there, you can see scrape config for Prometheus. Yeah, we could do that under the name of Prometheus. Should
So you were going to you wanted me to add a new job called Cortex rather than adding it as a new endpoint or target to the Prometheus.
yeah, yeah, that would be clearer because it'll
Yeah, so you
it'll
got to keep me right because I'm a bit of a cowboy when it comes to this stuff.
yeah,
I just wing it. All right, Cortex,
and it'll be
and
9009.
copied one too many.
And if you go to the top of the file, just so that everything is quicker, you can change the scrape interval to 2 seconds maybe, because you don't wait 15 seconds for every sample. Yeah, and everything should be fine.
All right, I trust you. So we
Yeah.
have cloned Prometheus. We built it from source. We should have the Prometheus binary,
Yes.
which we do, and then we're going to run it with the configuration which is modified.
Yes.
I like it when things work.
So
Okay.
now, now it should be pushing the data to, yeah, it's remote writing to what's it, Cortex right now. So if you could open the Prometheus UI, or even if you want to spin up Grafana and then we went through that, we can see if it's actually scraping Cortex and see the metrics that are ingested in the Cortex.
Yep. So by default, does Prometheus bind to all interfaces, or I tried? Do I have to do some asset compilation?
No, it should have been all fine. Or maybe we have to do asset compilation. We can do that.
Yeah, I think because all we did was build the Go command. We haven't actually did any of the React stuff.
Yeah, you can do a make space assets and it should be and rebuild the Prometheus.
Hold on, it's just taking a second.
Yeah,
I think it's trying to exit nicely.
yeah. It's probably trying to end the remote writing and then come back.
Oh, I broke Cortex with that. All right, we'll get it back up in a second.
I'm not sure what exactly happened there.
Prometheus is ignoring me, so I'm going to just do pkill. Oh.
Yeah, something has to happen in that.
Pkill 9. There we go. Right. So
Yeah.
make assets.
Asset
App install.
logs. Yeah.
Yarn won't be available because it has a special command. It's weird on the Ubuntu and Debian packages. Yarn is like this random thing, so I just
Yeah.
need to grab the command over here. I guess I should actually probably just do that here so people can
Yeah,
see.
that's unfortunate.
It's all right. It's a nice quick fix. So, oh, there is an Ubuntu version. Don't give me your nonsense.
Do you have like if you could install npm, you could install yarn with
Yeah,
that?
let's do that. So install npm. Typing is not my strong suit ever.
That was quick.
Yeah. The network connections are pretty solid in here on these machines, so it shouldn't take us too long. Once npm's installed, yeah, we'll just do the yarn way of doing this then, which was there is an Ubuntu package though, but I'm not going to fight with that today. We'll do that. Is that available in my
Make
path? No.
No.
Let's do x path equals path colon and user local lib node modules
Damn it.
dot bin. No, that is there, right? What did I get wrong? ls user. Oh, yarn is a directory with a bin. All right, let's just really fudge this for now.
Yeah.
Good. It doesn't have to be pretty, right? We just need to get it working. So
Yeah.
there isn't a Ubuntu apt repository. People shouldn't be expected to follow these horrible steps. But
Yeah.
all right.
Yeah. Now we rebuild after this. Okay.
Now,
So it
one
takes
thing
a
I can't throw hardware and npm install. Unfortunately, I think this might take a few seconds.
Yeah.
It's not too bad actually.
Yeah. We don't need much of UI for Prometheus. It's pretty simple.
Ironically, it may have been faster just to apt get install Grafana now that I think about it. Oh well.
Right.
And that's
Yeah.
sorry, on you go.
Yeah. The getting started has a step for Grafana.
Oh, it does.
Yeah.
Oh well, we live and we learn. Now, even though we have all these chords available, I don't even think that Yarn particularly or npm or Node particularly uses them. So, do I need to do a rebuild?
Yeah. Yeah. This is the thing. And run the Prometheus again.
I'll start Cortex first, and then start Prometheus, and then by magic, today,
Yay.
we got there. Okay.
Yeah. We can maybe run a query like you can say rate of Cortex underscore
Well, let me get them.
ingest.
Yeah,
Yeah,
I'll get
Cortex
this first.
ingester underscore ingested. Yeah, ingested samples total.
Ingested Sam. Oh, there we go.
Samples. Yeah.
And we want
And
to rate that.
rate or maybe 10
5 minutes?
seconds.
10
Yeah,
seconds?
the 10 seconds should be for the metric and not the rate.
Oh, I'm feeling it. PromQL. What did I get wrong?
Yeah. Like the 10 seconds and the square bracket should be inside the circular brackets. That's for the metric. And you can see the graph. There's a graph tab, yeah. And you can change this fine to 5 minutes, like the range of the query for 5 minutes. No, not there.
Yeah.
Below there, yeah. 1 hour is too much.
There we go.
You can see some samples ingested, and yeah, it's coming from it's going to Cortex, and Cortex is storing everything. That's sweet.
Excellent. Good.
Yeah, it's as simple as running a binary like both Prometheus and Cortex, and you have a Cortex running.
Okay. So Cortex runs. Prometheus handles all the scraping. There's
Yes.
remote writing into Cortex.
Yes.
That's it done. It worked, right?
Yes, it worked.
Okay. What's next?
Yeah, maybe I can explain a bit of not exactly the entire architecture. We could go back to the previous plan that we had. I can show a demo of horizontally scaling Cortex with other components involved, and then talk about the architecture, and we could replicate the thing on your machine. Let's see
Sounds good. Yeah.
how that
Let's
works.
do it.
It's good. Yep. Now I'm gonna share my screen.
If anyone watching has any questions, feel free to leave them in the comment section.
Yeah.
There we go.
So I'm reusing the slides by Marco, who is also an engineer at Grafana Labs and also a Cortex and Thanos maintainer. So I just took his permission to use his slides, so I do repeat the work. So this is the barebone Prometheus, which is scraping from service, and you can query. And I will jump to what we just did. By the way, here's Marco. Yeah. What we just did right now is this thing. We have a Cortex, and Prometheus is just pushing samples to Cortex. And when we want to query, like right now we queried using Prometheus. You could, in the Grafana where you have a Prometheus data source, you could point it to Cortex and insert query that. We skip that step, but I will include that in the horizontal scaling that we're doing. So right now we just had one Cortex. What we're going to try now is this thing. We will have multiple Cortex and Prometheus pushing to them. And for the object store, we will be using Minayo because we don't want to use the AWS or GCS anything right now. So I will jump to my terminal for horizontally scaling.
Could you just zoom in a little bit on that?
Sure.
Perfect, thank you.
So I am using, like under my account, I'm using a tree called demo. In the development branch, we already have like pre-built, like pre-specified Docker configs, like our Docker Compose config, where you can just run a single command to run the single binary. And with the horizontal scaling, I just created another demo, which a little more simplified stuff with all the things that we don't need. So I'll first run the demo and we'll go through what's there inside. You have to ignore the all this path thing because it's just a mess that I ended up creating in my environment. The only thing that's there here is compose up. Before that, let's see what all do we have in this directory. We have a compose up, compose down, where compose up just brings up the Docker compose and spins up multiple stuff. So I'm just gonna run the compose up. Okay, before while this is happening, we can go through the config that we have here.
Can you just zoom in a little bit more on that?
Yeah. So let's see what all we are running in this particular thing. So this is the Docker Compose config. We are running Minayo to mimic the ES3 or GCS. And then we are running the Cortex itself. We are, and I say we need console here, but why, we will get to that in just a second. We have a load balancer that will be the ingress, and this will pass on all the things to the Cortex. And we are running two Prometheus just to mimic the HA stuff, which will be pushing data to Cortex. If I'm going fast, just stop me and tell me to re-explain stuff. We have node exporter so that we can get some more traffic. Like Prometheus will be scraping Prometheus itself, like meta monitoring, it will be scraping Cortex, and node exporter just for some additional data, additional data. And we are running Grafana so that we can query Cortex. And we are running console, like we don't need console right now, but we are anyway running. Yeah. And let's and one small detail to know right now is we are running with a replication factor of 3, which means in this horizontally scaled stuff, whenever we get a single sample, it doesn't just go to one single Cortex, it goes to all three. So when you ran the Cortex data in your machine, it was running with replication factor 1. And when we are running with the replication factor 3, we need to have a quorum of two, like two Cortex out of the 3 should say that I have written this sample successfully. Only then the request can succeed. So if I move back to my terminal, you'll see lots of errors which say at least 2 replicas should be required, but it could only find 1. So what we will we'll see what's running right now. Yeah, we have a single Cortex running. So let's scale it to 3 so that these errors go away. Yeah, we have 3 Cortex running, and the logs. Yeah. It's getting to a scene state right now, I guess. Yeah. So basically what's happening right now is, let me go to the beginning where Prometheus is scraping and how it's pushing data. Okay. Oh wait, before doing anything, let's see if it's working properly. So this is the barebone Cortex UI that we have. There is nothing special. If you go to the ingest ring status, it tells you that there are 3 Cortex running here, and all of them have almost equal share of data that it's incoming. So that's all we need to know right now. Let's go to a fresh Grafana that's running inside. And we'll add a data source. So Cortex is 100% Prometheus API compatible even on the read path. Like read path and the push path, everything is Prometheus compatible.
Oh, nice.
So we will choose Prometheus as the data source. And because this Grafana is running inside the Docker containers and we have a Nginx load balancer, so we can point to that. And the Cortex, Prometheus APIs start with this prefix, so we mention that here, and we just say if the data source is working. So I'll run the same query that you ran right now, which is Cortex ingester, and we see the samples being ingested here. If I just go to last 5 minutes, something broke. No, it did not. Okay, we have some samples being ingested, like 3,000, 4,000 samples per Cortex. So this is one Cortex, this is second Cortex, this is third Cortex. So we have some samples incoming. Let's see. Let's try to scale up and hopefully it will redistribute the work it's doing. Maybe I'm going too fast, but I'm just going to verify if Prometheus is scraping everything. It is.
No, you're okay. It's all good.
Let's scale the Cortex to 5. We add 2 more. We got to wait for a few seconds. And we can check this ring status, which is available here. And we have 2 more incoming, all of them having almost equal share of 20%. Let's do
Okay, so
last.
can we explain some of the vocabulary here then? Like, what is a
Yeah,
Cortex ring?
yeah, we will go deep into that.
Oh, okay.
There are lots of things to, yeah, as in how time permits, we will go deep into that. So, uh, we were writing from 2 Prometheus replicas, and we are actually running 2 Prometheus replicas, which means it's HA, but Cortex also has the support for HA where it deduplicates stuff. So if I just quickly go through the config, we are saying that enable HA, and we use console only for the HA, where it elects one of the Promethei as the leader and only one of them is scraped. And if you go to the Prometheus config, it has a label called and a cluster, replica and a cluster. So for common cluster, it selects one of the replicas. That's how it works. And if you go to the HA tracking status, you can see which Prometheus was selected among the 2. So we are actually demoing, like, these are 2 HA Promethei going to the load balancer, getting deduplicated here, and we are just spreading out the Cortex. Now, you said you will talk about the ring. Why not? Yeah. So you need some kind of logic so that you can spread the writes equally to all the Cortex. We actually have that explained in one of the slides here. Why don't I reuse it? So let's say we have some random ring like this, and instead of 10, when we have 5 cortex right now, we will have 5 entries in the ring saying cortex 1 to 5. And in the config, we mentioned we want to have number of tokens as 512. So it will randomly select some number between 0 to the int max 64. And whenever a series is incoming, we hash the series, and the hash is between 0 to int max 64. And based on like which ingester holds the token for this particular hash, that sample goes to that particular ingesters. Did I make sense?
Yes. Can I try and then repeat that back to you in my really naive understanding, and we'll see if
Yeah,
that makes sense.
sure.
Okay. Can we go back to the diagram with the load balancer and the cortex in it?
Yeah, I'll go with this one.
That one. Yeah. Right. Okay. So we're. I just want to make sure I got this right. We run multiple Prometheus, each scraping the same targets. Let's assume it's within a Kubernetes cluster so that we have
Yeah.
highly availability. If one of those Prometheus goes away, it's still being scraped by at least one.
Yes.
Those Prometheus are being consumed by the Cortex. And the Cortex, it's not actually, if I understand it correctly, it's not actually doing deduplication explicitly, but it's actually doing deduplication by hashing the metrics and then sharding them across the many
Uh,
cortex. Is that
no,
right?
I
No?
think I think I got you confused here. So the when Prometheus is pushing samples to the cortex, it has some labels, additional labels, which says I am from replica 1, I am from replica 2, from the same cluster, and we have configured cortex to enable HA deduplication. So even before we do that hashing thing, uh, Cortex elects one of the Prometheus as the leader among those two, which we see in the HA tracking status. So it will blindly discard all the samples that's coming from one of the Prometheus, and it will only accept samples from second Prometheus and remove the replica labels that we have. So after that step, we do the hashing.
Ah, okay, okay. I got you.
Okay, yeah, now you can go ahead with what you're explaining.
Okay, so there is the deduplication based on the labels that has been added by the Prometheus. It's then hashed and then assigned and then replicated across the cortex is based on the replication rules that are in the configuration.
Yes.
All right, I'm with you now.
Nice. So let's say among these 5 ingesters, the hash went to, let's say, the cortex number 3. Let's say we have only 5 right now because we ran 5. Let's say the sample went to the cortex 3. So it will be given to cortex 3, cortex 4, and cortex 5. And in case a cortex has to crash, let's say 4 is crashed, it will still try to write to 3 of them. But once it writes to 2 of the cortex, it will return the request saying that, hey, uh, I'm done with the quorum of 2 out of 3, so I can return. But it will still try to write to another cortex, which will be the next cortex, which is 1. So no matter what, it will try to write to uh, 3 cortex, which is the replication factor, while satisfying at least the quorum. So that's how the replication works. And when you are querying, it will actually, like, there is something called query component. It will query all the cortex for the samples, because you don't know where you might have gaps because of maybe cortex rolling out or some cortex is down. So when you hit a query, it goes to all 5 cortex. All 5 cortex get, like, you hit a query to one of the cortex, it will send a query to all 5 cortex for the query, and the sample goes to one of the cortex where it originated. It mix and matches, deduplicate sample, and you finally get back the data to your Grafana.
Awesome, very cool. So, see the usage of console here, is that
Hmm.
because you're running this in Docker Compose? Like, I'm wondering if Cortex is running in Kubernetes, does it
Yes,
use the least capabilities there for the leader election without
yeah,
console?
that's a good question. So console, yeah, Cortex either needs console or etcd for this. HA like this HA tracker status, whatever you are seeing here right now is from the console. So for to elect a leader among the HA Prometheus, you need either console or etcd right now. And okay, I'm just hitting wrong tabs. uh, and this ring, initially we used to store even this ring in console, but now it uses, you can use gossip. The way we ran right now, the Cortex, it uses gossip to communicate among the Cortex, and the ring data is just propagated lazily to all the Cortex so that you can do the replication properly. Yeah, console is only required for HA. If you're not using HA, you don't need console.
Okay, perfect. Nice.
Yeah. Do you want to dive more deeper, or do you want to get hands on first on your machine?
Okay, let's. I mean, I think the problem with diving deeper is that we're limited by my knowledge. So why don't we get hands on? And if there's anything that people have in the comments, we can try and tackle that. Now, we have had a
Sure.
question which has been tackled by, I'm assuming, one of your colleagues. Rick asked, how does the member list ring works with Cortex processes split out? Where should the join members value be set? Context using Helm chart supported. I mean, I don't understand that question, but if you do, maybe you could try and
Okay.
explain that.
So should I point joint members to all Cortex? So I think there's a config somewhere here. Yes. So in the member list, we are saying get the DNS records of Cortex. So it asks the DNS for all the entries of Cortex, and on the 7946 port, like it is the default port that we use for member list. You can change it in the Cortex config. Okay, I don't think I was sharing my screen, my bad. Let me go through that again.
Yeah, I was just about to ask.
Yeah, I was just explaining
There you go.
the point. Yeah, so in the config we have this member list stuff where we are saying take the records of this Cortex, because in Docker Compose we are running it as Cortex, so the DNS entry will be as Cortex. And in the config we say take the DNS records of Cortex and do all the gossip things that you want on the port 9746. If you are wondering why 9746, let me go to the configuration. Let's go to configuration file. I can just search 9746, and it just happens to be the default that we used. You can change this member list config to bind to any port and then use that port here. So that's how you specify.
So that DNS plus Cortex, is that doing like a headless lookup, fetching all the IP addresses that resolve to Cortex and then
Yes.
discovering them that way, right? So, okay.
Yeah, I'm doing gossip over this port.
Okay, got it.
I
Makes
hope
sense to
that
me.
answers.
Yeah, I understand that. I don't know if it answers the question specifically, but Rick, feel free to get back in touch. And I know that Hula has also replied, so hopefully that covers
Yeah.
that. Why don't we get it hands on, just hands on again, and we'll take it from there. So I should be able
Yeah.
to replicate this, right?
Yes.
That's what we're
Yeah.
gonna do. So
Yeah. You might want to now clone my demo because the one in the upstream is little different.
all right, let me SSH onto the first node again, and we want to clone https github.com /cortex
Cortex. Right.
and cortex codesum. All right.
Yeah.
Uh,
You go to
oh,
Cortex.
yeah. Just always my typing that lets me
Yeah.
down. Okay, so
You can
where's
go into development and then, oh, why do, yeah, you should fetch the demo branch. My bad. The master is sync with the upstream. Yeah.
demo, right?
Yeah.
Okay.
Yeah. And you can just do /compose up and everything should be up and running. But we have to scale up Cortex as we saw before.
Okay, and that's just going to run this, which we've already went over. So it's going to run Minio,
Yes,
which gives us an S3 compatible uh, blob storage on
yes,
this. We run Cortex with the configuration. We're running a load balancer for the Cortex. And then
yes,
we have our two Prometheus, which is our HA scraping. We've got a node
yes,
exporter, which I'm assuming we're just grabbing some metrics from. And then we have Grafana and
yes,
we have console. So we covered all this. We can run
yeah,
compose up. And it's just going to pull down some Docker images. But again, it
yes,
should be pretty quick, I hope.
yep,
And I'll just put that repository back on the screen. So if people want to play with this in their own time, you can clone that repository, check out the demo branch, and run this yourself.
yeah. Also, if you want to just run the upstream demos of Docker Compose, you could also do that. It's straightforward. It explicitly mentions Cortex replicas, but in this demo, you can dynamically scale up and scale down. That's the only difference.
Okay, cool. Is the there we go. Ah, so the ports are being used. So I should probably shut down the other
Done.
stuff.
Yeah, yeah, yeah. It's using the Prometheus port 9090.
Cortex.
Yeah, Cortex was already done. This is Prometheus.
Yeah. Okay. Cool.
Yep,
So let's just run that again. All right, and it's up.
yeah.
So we
And you
want
should be getting some error message. Yes, we want to scale up the
yeah. So
Cortex.
the error message here is just saying that could only find one, and we need at least two, and that's just so that we have a quorum on the Cortex cluster, right?
Yes,
So,
yeah.
so if I go to the Cortex code sum development demo, and then we can do a Docker compose
Was
scale
Cortex.
Cortex 5, right?
Yeah, we can do 5. It should Cortex equals to 5, I guess.
Ah, Cortex equals 5. And
And
then we
yes,
should see, I guess it might just take a few seconds, but the error message has gone away. We can see now other
yeah,
thingies and stuff happening. So,
yeah, yeah. And to see everything in action, you can open this IP on port 880 on a browser and see all the Cortex running and the HA status. Oh, why is it bad gateway?
dun dun
Can you see
dun.
the terminal if it said something?
We're getting a connection refused upstream.
No, what's wrong? I just ran that. Maybe
Okay,
try
so
it again. I'm not sure.
let's take a look. Right, so we can do a Docker compose PS. Let's just make sure everything is
Yeah.
running.
Yes, everything is fine.
Let's just
And
see.
load balancer. Yeah.
Yeah, it's definitely. Let's see. I'm usually good at fixing broken stuff, so let me see. So, is this something to worry about? Should we just? Is this a red herring? But we have.
No, that's fine. That's
Okay.
totally fine.
Right, so the only problem we have right now is engine X. So let's take a look
Yes.
at what's going on with this load balancer setup. So if I do a docker compose exe load balancer bash, and we'll take a look at the engine X config, and let's see cortex.yaml. Ah, of course. Let's just cat it.
Yeah.
Well,
Nginx config.
yeah,
Yeah,
let's put the
Nginx
right
config
file.
should be Nginx conf. Yeah, it's pointing to Cortex.
Okay, so it's just doing a proxy pass to Cortex as a DNS name. So let's curl Cortex. And that looks okay, right?
Yes. If you do Cortex 880, no, Cortex should be on port 80, but
Yeah. So from the host, let's try localhost 8080 that gateway.
that's
That's
strange
interesting.
because we are pointing the load balances 80 to localhost 8080.
Yeah. Okay. So why is Nginx unhappy? even though it looks like to me it should
Yeah.
be working upstream. That is really weird. I'm gonna restart Nginx.
I think we want to compose down once because it failed initially, or did it not? I don't remember.
Yeah, I guess yeah, let's do that then before I start just kicking things. Okay,
Yeah, we can
so
do dot slash compose down. Yeah, dot compose down, or yeah,
I'm
it will
trying
stop.
my best. My brain says one thing, my fingers type another. It's a common problem. All right, let's run this back up again.
And we have to scale up again. Hopefully everything is fine this time. Yeah, let's scale this up again.
Okay, Cortex, codes on development demo, doc. Oh, let's just scale. Ah, Cortex equals 5. All right, so we should see those errors disappear again, which looks good. There,
Yay.
transient error.
Yeah.
All right, so
So
what we're
if you
saying
got
is,
ingester ring status, we'll show you that we are running 5 of them.
all right. I mean, that's pretty simple then to scale horizontally. Like, I mean,
Yes, you
can I
can
pick
just,
any number there? Like, if I'd scaled this, let's say I do 50. That's probably a really
yeah,
stupid number. I'm now
yeah,
instantly regretting that.
yeah.
But
Let's not scale down now because scaling down requires you to scale down one at a time. So that's going to take a lot of time. So let's play with 50 right now.
okay, sorry. I should have run that past you first. But I mean, that's pretty cool. We've just scaled up our
Scaled.
Cortex to 50
Yeah,
nodes, and
yeah.
they're
It's
slowly
pretty
coming in
simple.
active. So
Yes.
nice. Uh, okay, so yeah, if we zoom out a little bit, all right, good. So I think still a couple pending, but it's getting there. So
Yeah. We have 50 Cortex running.
that's pretty cool. Like
Yeah.
I can just scale that to. And what are the scaling constraints on Cortex then? Like when do I scale up Cortex? Is it depending on how much data I have coming in? Does it ingest
Yeah.
control, flow rate,
So
like cardinality? What are the constraints there?
so there are a few things. Like one is the write, which the like I can actually go through the architecture right now and talk why when would you split it into microservices mode and what component is hit by what.
Yeah,
Does
go
that
for
sound
it.
good?
That'd be great.
Yeah, I'll actually share my screen. It will be easier to show the architecture with that. Yeah. Is my
Yep.
screen visible now?
Yep, it
Yep.
is. We can see the hash string.
Yeah. So where is the overall architecture? Sweet. Yeah. So when you ran a single Cortex binary, it is actually running all these components inside a single processor. So these are all the components that you have. So in the right path, we encounter distributor and ingester. The ingester is the final place where the data goes. It stores it in the memory. Ingesters have the tokens, etc. And distributor reads the ring, determines which ingesters it has to go to, and then it just sends the data to the ingester. So if we take the ring page, when we have 5 cortex, or let's say now we have 10 cortex, when you hit a cortex for ingesting the sample, you hit the distributor component and it selects 3 of the cortex and it goes to the ingester component of the cortex. So that's the right path. And when we go to the read path, the query front end does some query optimization or like splitting queries into multiple queries to parallelize the queries and all other stuff. And then sends those parallel queries to a component called querier. So querier actually directly uses the PromQL engine that we have in Prometheus. So it's 100% PromQL compliant. So querier asks for, yeah, when ingester has data which is old, it pushes to the Minayo or the object store that you have. So querier gets the recent data from the ingester, old data from the store gateway. Store gateway is just another component to interact with the object store. Querier gets the data, runs the queries, sends back the data to query frontend. And because query frontend gets the data back from multiple queryers, it again merges the data and sends back to the uh, querying tool of your choice. Compactor is just another service which merges all the data here. So now talking
Okay.
about where would you like all that I explained right now, does that make sense?
Yeah, I mean, I have one question looming in my head, and is that we're scaling Cortex as a single binary. Is that how I
Yes.
scale it, or can I build those components in isolation? Do I scale them all together?
Yes, I was going to get to that thing. So let's see what are the bottlenecks when you scale, like run Cortex at huge scale, and how do we split this into multiple things? So in the right, if you have only a write heavy cortex, then the distributor and ingester will be heavily loaded. And if you query anything because it's a single cortex running, your queries might suffer because of lots of writes. Now let's see the other way around. You have lots of heavy queries running, like spanning over days, touching all the cortex instances, and then uh, because of that, it takes lots of CPU, and your writes are suffering here. So you could scale out Cortex horizontally with a single binary as much as you can, as long as both of these are working fine. But when one of the read path or write path is affecting the other, there you would want to split this into multiple components. So what's beautiful is you use this uh, single binary itself to run multiple components. For example, uh, I have Cortex. By default, it has something called target equals to all, which is the single binary that we ran right now, which runs all the components inside the single process. So you could just say, just run the ingester, and
Ah,
you don't want other components.
nice.
That way you can, yeah. I think we have, yeah. That way, this is again a Cortex binary, Cortex binary, Cortex binary, but you are running distributor ingesters separately, and you get to one of the distributor, you have a load balancer in front. Like you can have, this is a multi-tenant system, but it Cortex does not itself implement any kind of authentication, so you need some kind of authentication in front. You go to one of the distributors, and everything is like before. You can consider this as one of the Cortex, which takes the sample, flushes the blocks, it goes to the Minayo. And in the query path, again, this is a Cortex binary, but target as query frontend, another Cortex binary, target as querier. So, and once you have this architecture up, if you are getting more and more writes and not much reads, you could just scale up this distributors and these ingesters. And one rule of thumb that you could follow is, or what we follow is, you can limit the amount of memory each ingester is taking, or the amount of uh, series each ingester is handling based on your machine size. So whenever you are hitting that limit, you scale out the ingesters, and if distributors are not able to send the samples to ingesters, you scale out the distributors. And query, yeah, query, the more queries you are getting, you just scale out the queryers. Query frontend, you can just do it too right on. We cannot scale out query frontend right now, but we would be able to do it soon, I guess.
But I guess that's pretty standard practice. Like if I think about all the production systems I've operated over the years, like the right path is where the traffic is. You know, the queries of the
Mhm.
dashboards that we open when things go wrong, and not
Yeah.
necessarily something we would have to scale independently.
Yeah, yeah. But what happens is, when you have this long-term storage, a few folks like to have a dashboard open all the time, which might span multiple days. So it's constantly hitting the server with heavy queries. So if you have one of such users, then you could see yourself splitting. Like you could even have a binary running both distributor and ingester. It's not like you want to run a single way. If you want to split, you don't need to run a single component in a binary, you could have distributor ingester as a single binary and only split out querier outside. You can also do that.
Okay. So can we? There's one thing that we've not really looked at yet, but we are running Minio, right? So all of our data right now is being stored on an S3 compatible store,
Yes.
right?
Yeah.
Uh,
First it stays in the ingester in the memory and the writer log. After some time, yes, it goes to the S3 compatible storage or
okay,
GCS or anything else.
so it stays on the right ahead log until it has to be flushed to disk, and that flush to disk is then to the S3 compatible store.
Yes.
Okay, cool. I like that. It's very cool.
Yeah. And what's beautiful is we are reusing the Prometheus data storage. Like Prometheus has blocks of data, so we are recreating the exact same blocks in these ingesters, and we are just flushing those blocks in the S3 compatible storage or GCS.
Okay, and is Cortex like on the query side? Then is it doing any sort of cache to avoid lookups on the
Yes,
store? Right.
yes,
Okay.
yeah. So the query frontend has cache, which caches based on the time range and the query that you have. So it can also do partial querying. Like for in Grafana dashboards, you can have, yeah, you can, when you refresh after every 5 or 10 seconds, you don't need to query for the entire range, but you just need to query for the last few data points. So this cache even takes care of that. So you just query the only thing that you require.
Nice. I like it.
Yeah, and you also cache like queries needs to fetch the data from store gateway and ingester. So querier also caches all the data that it can fetch from these. It query frontend caches the final result. Querier caches the raw data. So we just cache everything that we can.
Cool. Excellent. Is there anything you want to cover then before we
Yeah,
finish
I
up?
would. Yeah, for users who want to try out, like I will just switch to master just to show what's there in
Oh,
upstream.
cool.
If you want to like run these Docker Compose stuff in your own machine, in the development we have three things already set up for you. I'm not really sure about this thing, but this single binary mode will run the individual Cortex in a horizontally scaled way. So you will have, I guess, 2 or 3 Cortex running, but in a single binary mode. And if you want to run this setup where you want all the individual components separately, so you choose this. There, if I want to quickly have a peek, yeah, here you will be running the distributor, ingester, and everything else separately. So if you want to play around with single binary or even the everything split out version, you have it ready. Yeah,
All right.
I guess that's it.
Nice. So let's finish with like I'm trying to think like a pragmatic approach to people with their metrics, right? Now, the vibe I'm getting from the conversation and what we've seen here is that it's probably realistic that people are going to start with Prometheus in their cluster, and then there's going to be a certain
Yes,
point where they want to then bring in Cortex for the
yes,
durability, the high availability, the multi-tenancy, which is really cool,
yes,
and all these things. Like, so is that the best approach for people to take? Is to run Prometheus, and then when X, Y, and
yes,
Z happens, that's when you go right. You need to start
yes.
bringing in Cortex now.
Yeah, if you have small Prometheus installations and like if you care about centralized view and all the things that we discussed right now, only at that point you may want to start looking at Cortex. Until then, if the scale is small, you could be all good with Prometheus because Prometheus scales really good in itself.
But vertically, right? That's when we talk
Yeah,
about scaling
vertically.
Prometheus, we're talking about
Yeah,
vertical. So if you can
vertically.
throw loads of really strong bare metal hardware at it, then cool, right? Prometheus
Exactly.
is going to get you a
Exactly.
long way. Uh,
Exactly.
nice, okay. And the does it make sense to just even adopt Cortex purely for the S3 compatible backend as well? Like, I'm assuming that just might be enough of a selling point where people want to be able to rotate the hardware and still have that backing data store. So S3 could be a really good
Yes.
stopgap for that too.
Yes, you could just have Cortex just as a, you can say, backup data which takes the data, but you could also have a look at Thanos. Like if you just want the data to be backed up somewhere, Thanos has more simplified thing where it just ships the block to your S3 compatible storage, and if you want to query later you can just add one more component.
Wow, that's
Yeah.
that's
Yeah,
completely serendipitous.
yeah,
Yeah,
that's a,
serendipitous. Is that I have Thanos 1 week today on the show. We're taking a look at that there, so
yeah,
people can
yeah,
come and take a look at that.
yeah, both have different, slightly different approaches and different goals. When you have huge scale and want a proper centralized view with multi-tenancy, Cortex makes proper sense there.
Awesome. Any final thoughts before we finish up for today?
Just try it out. It's pretty cool. Like the initially when Cortex came, the everyone saw the architecture diagram. They got scared. It's pretty very complex. But
Yeah.
if you saw it here, you could just do /Cortex and you have Cortex up and running.
Yeah, there. I mean, personal experience here. There is an intimidation factor when you.
Hmm.
So many of the talks are really, they go deep into Cortex and all the different components, and it can be a little bit intimidating, especially when you see people talking about the Cassandra components and all this other stuff that
Yes.
can come in. But I think
Hmm.
what we've seen today from your demos and from what we did hands on is that that's all optional. Like you can get
Yeah.
started by running the single binary and running
Yeah.
Prometheus,
It's
something
pretty simple.
that we're all comfortable with. And
Yeah.
you can then layer on those extra components. You can bring in console
Yes.
when you need HA and deduplication. You can bring in S3 when you want extra storage options. You can bring in Cassandra when that is available to you. So I think,
Yeah. You
yeah,
don't
great
even
job.
need Cassandra. You don't at all
I
need
do-
Cassandra with Philosophy.
yeah, I think I'll avoid that whenever possible, to be fair. So,
Yeah.
all right. That was awesome. I'm really impressed. I think it's a fantastic
Yeah.
project, and I'm really looking
Yeah.
forward to seeing what comes next. So,
Yeah.
thank you
Thanks
for
for
joining
having
me
me.
today, Ganesh. It's been an absolute
Yeah.
pleasure. I hope people take a lot of value from this, and have a great day.
Yeah. Thanks for having me.
Cheers. Adios.